Thank you.
Hi, everybody. Thank you very much, Paul. It's a great pleasure being here and being able to share the designer's perspective of low carbon infrastructure. So let me start with this. So I'd like to start, just put it in perspective first. What does infrastructure, carbon in infrastructure look like? And I use the UK as an example. So we have a legal obligation under the Climate Change Act of 2008 to reduce our current carbon emissions that are almost a gigaton of carbon dioxide per year, down by an order of magnitude almost by 2050. And infrastructure plays quite a big part of that current carbon footprint. It's more than half of the UK carbon footprint. So from the designer's point of view, we need to get thinking, completely overhauling the way we're designing infrastructure. It is very much about, and we heard a lot about reducing the carbon intensity of our materials, producing a very efficient design and all this, but it is also about recognizing that infrastructure assets, we're designing something that is a capital carbon and cost investment for making sure, for enabling a low carbon operation of our society as a whole. That is what the purpose of infrastructure is about. So as part of our design, we should be able to be talking about hard-working infrastructure assets that potentially do a lot more than one tasks. We should also be thinking about the each infrastructure asset is part of a system, and designing it should enable that system to perform better with reduced carbon emissions and much more efficient. And essentially have treating the design of our infrastructure assets as a capital investment, not on minimum capital cost anymore, but on maximum whole life value. So my examples will hopefully try and address these points. What would that look like? I do start with a UK example. This is an example of a multitasking infrastructure asset. It is a water treatment up in Yorkshire, so it treats wastewater, but in doing so, it also generates energy from the flow of the effluent it's trying to treat. And that reduces significantly the operational carbon and cost of this asset. And there is potential to use that energy not just as part of the treatment, but elsewhere. As an example of designing by thinking around systems, not just assets, this is an example in South Wales where increased capacity again of surface water treatment was required at the end of a large catchment area. By thinking about investing a fraction of that cost and carbon money that a increased treatment system would have costed in creating features upstream within the catchment area to avoid surface water runoff, there was a really significant carbon and cost reduction during construction, but also throughout the operation of the system. My third example is about existing infrastructure assets. So this is a small project we did with London Underground on upgrading the passenger capacity of existing London Underground stations, in this case in Elephant and Castle in South London. So most of the developed countries have already got the majority of the infrastructure already in place. But this infrastructure is either aging or not fit for purpose or needs a big push to become functional and efficient again. So purely the fact of this passenger upgrade, taking 27,000 passengers at peak time per day off the carbon-heavy roads of London and into the existing Victorian railway system in London has quite a major carbon reduction potential. And of course, we will be designing this further for capital and operational carbon and cost reduction as for the design of the building itself, but it's the system, the transport system of London that also benefits as a result of the problem. And this is an example of a master plan in a suburb of Muscat in Oman. Madinat Al Irfan is a sort of a showcase of how thinking about carbon reduction and efficiency of a system gives you much more significant savings of carbon and cost than just the sum of the individual carbon reductions you can achieve at individual parts of the system. So with the same or similar capital carbon and cost investment as the business as usual, let's say, master planning approach of a development, you can achieve at least 50% of operational user emissions over the first 20 years as a comparison stage of this project, and pretty substantial cost savings as well. And thinking around, and I'll use the railway tunnels as an example of what this capital investment for a whole life of value could look like. We traditionally design infrastructure or railway tunnels as small as possible, yet still do the job of carrying trains through them. But the study on the left-hand side, a small study we carried out on the energy efficiency of the train that runs through them, it shows that a very small increase of the tunnel diameter can result in significant energy efficiency of the train that runs through it. If you multiply it by the number of trains that go through this tunnel of 120 years of its operational life, that adds up to an awful lot of savings, which is more than pays back the initial capital carbon and cost investment. And since we're putting a lot of tunnels in the ground at the moment because trains in urban environment are becoming more and more commonplace, how about putting some heat loops in the tunnel lining as well, not only to reduce or control the temperature within the tunnels themselves and avoid the additional MEP requirement for cooling the tunnels and stations, but also use that waste heat to decarbonize the supply, to decarbonize the buildings above ground as well. So, in conclusion, there is something we should be thinking about as designers as a capital investment for whole life efficiency. we should be thinking about how do we maximize the function of the existing infrastructure. It's not just concrete and steel, it's something we put in place because we need to use it as efficiently as possible for a very long time to come. And there are huge opportunities, carbon savings that we haven't thought about yet at the interfaces between the different components of systems, which can achieve much bigger carbon savings than the individual parts. And on that one, thank you very much for your attention.